So this is geometric sequences introduction, and so again I would be defining a geometric sequence here, but before I do that, just to go over an arithmetic sequence, that was a sequence where there's a constant rate of change. For a geometric sequence, the basic thing that you have to understand is that there's a common ratio. And when I say a common ratio, I'm really talking about a certain value that each number is being multiplied by. For instance, let's say we have 4, right? 4, and then we see we have 16, and then we see we have 64. So we see that 4 is being multiplied by 4 here, 16 is being multiplied by 4 here to get 64, and so on. And so there's that idea of a common ratio, right? And you can obviously find the common ratio by dividing 16 by 4, that's 4. 64 by 16, that's 4. And so really dividing any term, as long as those terms are consecutive, right? You divide those terms and you see that you get this specific ratio, and obviously this ratio must be constant. And only if it's constant does that indicate that this is a geometric sequence. So that's the basic idea here behind a geometric sequence. Again, there will be several formulas here as well, but just to get the basic definition, a geometric sequence is a sequence that has a common ratio. So now to find the nth term, right? Nth term here. A(n) is equal to A1 times R, and then we have power of n minus 1. And obviously, because it's PEMDAS, right, we do the exponents first, and then we will be multiplying that value by A1. So this is the formula that we use here to determine the nth term in a geometric sequence. So for instance, we may be given something, I don't know, we can have, so let me just give you an example. A(n) is equal to 3, and then we have 3 here, and minus 1. Now if we think about this, right, our sequence here is 3, 9, 27, 81. And so you see that 3 here is A1 because 3 is the first term, right? And then you're looking at the R is your common ratio. Well, you can do 9 divided by 3, that's 3, 27 divided by 9, that's also 3, 81 divided by 27, that's also 3. Doesn't matter exactly which numbers you divide, as long as you're dividing those consecutive terms and you're getting that same output, in this case being 3, that 3 is your common ratio here. And so this is a formula that you have, and really it makes sense because you really need the first term and the common ratio to find the value of any nth term now. So you just need to know this formula, and we can derive this formula by looking at even the first 3 terms or even the first 2 terms, because we need to know the first term and then the common ratio. And if you want to check, you have 4 here, this is a 4th term, 4 minus 1 is 3, 3 to the power of 3 is 27, times 3 is 81. Now if we want to find the 5th term, right, we already know it should be, well, it's 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. We know that 81 times 3 must be 243, right? And the 243 here would be the 5th term. So if we do substitute 5 here, that would mean that A5 is equal to 3 times, so we have 3 to the power of 5 minus 1, which is 4. So 3 to the power of 4 is 81, and times that by 3, we see that the A5 should equal 243, and certainly it does here, as you can see. So this is a formula. A(n) is equal to A1 times R to the power of n minus 1. So just know this formula, and really you're really just substituting the values into the formula. So that's just the introduction to geometric sequences. Thanks for watching.